Hi everybody, so today we're going to talk about types of alcohols, which I said I would mention in the last video. So I'm going to discuss that with you, and then types of chemical reactions, and if we have time, hopefully we will look over some experimental techniques just to give you a brief introduction. How do people actually figure out what molecules look like in the laboratory without actually being able to see them? So let's talk about alcohols a little bit. And this is actually something that is not really on the Regents, but I think it would be interesting for you to get a good idea. It's a term that's used a lot, and that is the type of alcohol, primary, secondary, and tertiary. So when you have a 1' like this, it means that it is a primary alcohol. And what that means is that when we think about a primary alcohol, we think about the OH being at the end of a chain. And so, for example, if I were to have something with 4 carbons in it, and then I were to attach my alcohol group, my hydroxyl group, I would attach it to the end. Now, why do they call it primary? Well, if I fill in all the hydrogens here into this chain, primary alcohol means that the OH is attached to a carbon that is attached to only one other carbon. That is why they call it primary. So the OH is attached to a carbon at the end of the chain. Now, if it's secondary, then it has an OH attached to a carbon in the middle of the chain. And technically, what this means, the reason why they call it secondary is because the carbon that is attached to the OH is attached to 2 other carbons. That is why it is secondary. The carbon that the OH is attached to is attached to 2 other carbons. And then I could have a situation where I have a tertiary alcohol, and a tertiary alcohol would be where we have the OH attached to a carbon in the middle of the chain, but this carbon is special because this carbon is attached to 3 other carbons. And so the common name for this alcohol, because it has 4 carbons, is actually called T-butyl alcohol. But the IUPAC name would be 2-methyl 2-propanol, but people call it T-butyl alcohol commonly. So these are the different types of alcohols. Now also, I could have more than one OH group, which is going to be a little bit different than the situation that we saw with where replacing the OH group. If you're monohydroxy, you would have one OH attached anywhere you want. Primary, secondary, doesn't really matter. It would be one OH. All of the ones that I drew up top here, primary, secondary, tertiary, those were all monohydroxy. They all had one OH. Dihydroxy is a compound that has 2 OHs. And this is actually a very common molecule. This is called ethylene glycol, and it's antifreeze. And then a trihydroxy is with 3 OH groups with all of the hydrogens attached, and that would be a trihydroxy that is called glycerol. So these are some common types of alcohols. Let's talk about the reactions. If we go down to slide number 31, there are 7 organic reactions that you need to know. I will try and go through some of them today, and we can finish off the other ones tomorrow. So one of the types is called an addition reaction. An addition reaction is where you have an alkane or an alkene, or I'm sorry, let's repeat that. Where you have an alkene or an alkyne, it needs to be unsaturated. So an alkene or an alkyne, and you add either a halogen to it or hydrogen to it. So for example, if we were to use an alkene like ethene, and we were to add chlorine to it, well, chlorine would add to the hydrocarbon breaking the double bond, and we would get this. And that would be my addition. Could I do hydrogen? Sure. So I could do hydrogen to this, and then I would just become a saturated alkane. Like this. Now if I had a triple bond, you can try this one. What if I had ethine and I add a, let's say, bromine to this? So add as many bromines as you need. Let's see what products you come up with to add that as an addition reaction. Okay, substitution is sort of like a substitution in sports. If you have a team sport and you have players who are not playing, they're on the bench, you would put one of those players in, and then one of the players would come out. And we can see that here if we were to have something like ethane, and we're going to label this H with red right here. I have to find that purple color again. I think it was this one. Okay, so we have our H right there. And now we would add our halogen to this. So this would be alkane plus halogen. And so what we get is, we get a substitution. So now the Cl will go in for that H. The other Cl will pair up with the H that was replaced. So we'll get this product. So now we'll get a halide, and we'll get an acid. And I can do this with any of the halogens. Why don't you try one? Let's try one where we do, why don't we try like propane, C3H8, plus let's do iodine. And let's see if you can come up with the products, and we'll talk about that in class. Okay, combustion is where you take any organic compound, and we've talked about this one before. Any organic compound, usually they stick to either the hydrocarbons or they do alcohols. That's what I most likely see. Although, you know, you could do it with organic acid, you could do it even with compounds containing nitrogen. But generally we'll have this, and then we will combine it with oxygen, and we will form, if it's complete combustion, CO2 and H2O. If it's incomplete combustion, you'll get other products, like you'll get carbon monoxide. But an example of this would be, for example, let's say if I had C4H10 and I added O2 to this, and I produced CO2 and H2O. The only difference that you're going to get is how to balance it. So if I went ahead and I try to balance this one, I would need 4 of these, and I would need 5 of these, and that would give me 13 O's. And so then I would need 6.5 O's here. If they want you to balance this based on lowest whole numbers, you'd have to double everything in order to do that. Okay, the next type of organic reaction is an esterification. Esterification, you combine an alcohol plus an organic acid, and you catalyze this with sulfuric acid as a separate acid that's added, and you'll produce an ester in water. This is the first type of what they call a condensation reaction. So let's say that I were to have ethanol, and I were to combine that with, let's say, propanoic acid. Now I'm going to draw the propanoic acid with the functional group on the left here, just to show how they combine together. So what happens is we take out the water, so the H and the OH would come out, and that will be our first product. So we'll have HO, and then we'll have our H from the alcohol, and then we'll form our ester. So then we'll have plus our alcohol without its H, and then we'll have our acid attaching to it. And so our acid, if we go back to the color we were using, I think that was the color we were using. If we go back to the color we were using, we're going to have our 3 carbons with our double bonded O. And if you look on table R, you'll see, oh yeah, this is in fact an ester that he drew here. Now, when we name the esters, remember that there's two parts. We have, this would be called ethyl propanoate. And now it may help you a little bit, propanoate. Now it may help you a little bit because now maybe you'll see that the ethyl group came from the alcohol, so the YL comes from the alcohol, and the anoate came from the acid, from the propanoic acid. All right, polymerization is where you take many what they call monomers, and you combine them together to a polymer. So with addition, you're going to break a double bond, and you're going to link the monomers. And usually do many of these. So I could have something like this, where I have double bonded ethene, and let's say I have 50 of these, and then I'll link them together, and they'll show it like this. They'll show them linked, and then they'll draw a little 50 down here to show them linked together. So we go from ethene to polyethene, or polyethylene as it's called. Condensation is where we remove water. So we need to have some oxygen-hydrogen groups on there. So we would have something like this. I'm just drawing like, so we'd have something like this group right here, and then we would have repeating units of it. Oops, I don't want to paste the image. That's weird. Can I undo? Delete? How about we just paste? Okay. And so now, if we link these together like this, and we put them together, then we're going to get rid of the water when we do that. That's why they call it a condensation. So we're going to have this. We're going to link them together. We're going to have our HO, then whatever carbons were there, and then an O, and then we're going to link it to the next group like this. And as the process goes, we'll remove water. That's why they call it condensation. And this is linking by removing water. And that's exactly what we do. And here are some examples of common, polymers. A lot of the addition ones are artificial. We make them in a lab. So polyethylene, these are types of plastic. Remember, you have these marks on them, and some of these plastics are not really good they leach into the food, and people are concerned about that. Polystyrene, and then Teflon, and this has also been controversial lately. When you heat up the Teflon, what happens to the Teflon material? Does it leach into the food? And if it leaches into the food, does it cause damage to people as they eat it? Here are some other ones that are made from condensation, and sometimes the SAT and even the Regents ask you about artificial versus natural. Things like cellulose, these are made by removing water. This is found in plants, it's natural. Proteins found in humans, plants, all organisms. This is natural as well. But something like nylon and polyester, those are not natural, those are artificial. Those are made in a laboratory. Another type of reaction is saponification, and this is where we take some kind of fat that is, normally from vegetable oil, although you could use animal fat as well, and you add NaOH to it. You produce the soap molecules, and you produce glycerol, which is that trihydroxy alcohol that we had before. Now, something interesting about this is that the soap actually, when it combines, the sodium ion from the NaOH will combine with the long hydrophobic tail of the fat. And this leads to a structure that is both hydrophobic, meaning it doesn't like water, and hydrophilic. And the idea behind this is that the hydrophilic can interact with the water, the hydrophobic can interact with the dirt and grime and grease, and then you actually can get clean from this. All right, fermentation is where you take a sugar and you use yeast, which have certain enzymes in them, and you produce ethanol and CO2. This is the most common kind of fermentation. You could also make methanol too if you have something like wood and you try and ferment that, but this is the most common kind of fermentation. All right, so next time we'll talk about organic reactions that include oxidation of alcohols, and we'll talk about fractional distillation of hydrocarbons, some of the experimental techniques. That'll be a pretty short video, and the last video for this unit, and actually for the year. All right, thanks so much.